Okay, we're looking at page 61. This is the fourth assess. There I'm working with grade B questions only. Remember, you've got to look at the original links at the top where it says link to essential foundation videos. Got to look at those first really before we go any further. Got to get the foundations right. I keep saying that. So anyway, this is question 6 on page 61. It says Fula got 32 out of 60 for her first math paper. Okay, over half marks. She sits the second paper next week. It's out of 75. Now Fula needs to get an overall percentage pass mark of 60% to get her maths, essentially. So what mark does she need to get on the second paper? Well, 32 out of 60, all right, plus something out of 75 has got to equal to 60. So essentially her overall test score will be out of 60 plus 75, 135. So if she's got to go out of 135, she's got 32 already, plus she needs something. Let's just call it x, and I'll put the x in the table, then you know what we're talking about. And that's a fraction, obviously. When you multiply the fraction by 100, you change it into percentage, and that's got to come to 60% to pass overall. So we've set up a very simple equation: 32 plus something, x, over 135 times 100 would come to 60. Well, first of all, let's just get rid of this times 100 by taking over and dividing, and we're left with 32 plus mystery x divided by 135 will come to 60 over 100, or 0.6. So this fraction equals the decimal 0.6. Rearranging, the 135 goes next door and multiply. So 32 plus something, in other words the something is the mark for paper 2, that's going to be 0.6 times 135. Let's just get a result for that first before we go any further. So 0.6 times 135 is 81. So 32 plus the extra marks she needs, it's got to come to 81 marks overall. Right then, so the marks she needs in paper 2 is going to be 81. Take away the 32 marks she's already got, and that leaves her with, let's just take it away because I've got a calculator, leaves her with 49 marks to get. Not 49%, she needs to get 49 out of, gone glitchy again, she needs to get 49 out of the 75, and she's got 60 overall. So that's the first question done. Question 7, let's see how this goes now. Question 7, page 62. It says, in a survey of 300 students, they're asked how they travel to school. 70% said they use public transport. Of these 70%, 90% said they travelled by bus. So got the picture, 300 kids, 70% said we use public transport, and of those 70%, 90% of those 70% said they go by bus. Question, here it is: how many students in the survey travel by bus to school? Now we can do it the long way, and this is the long way. Work out 70% of 300. Well, let's just do it the long way, shall we? Well, that's going to be 70 over 100 times 300. Cancel a few zeros. Doink, 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 doink. So I've got 70 times 3, I've got 210 students. And then it says 70% say they use public transport. Yeah, that's that many use public transport. Of these, 90% say they travel by bus. How many students travel by bus? Okay then, so it's 90% of these students travel by bus. In other words, 90 divided by 100 times 210 equals, well, let's just chop off some zeros. You can cancel with you, you can cancel with you. 9 divided by 1 times 21. So 9 21s, 9 times 21 comes to 189. Final answer, 189 students out of the 300 said they travel to school by bus. Now this is the higher paper, please, let's just do it in one step. This is how it's done. Now look at the English again. Let's just go back to my question. 300 students, of whom 70% said they travel by public transport, and of these 90% travel by bus. And there it is in one step. 300 times 0.7 times 0.9 bang, the answer is going to be 189 in one step. And that's the clever grade B way of doing it. Just check it. So 300 times 0.7 times 0.9 equals. Can you see that? Well, I'll make that 189. So it works a treat. Okay, so be smart, save time, do it the nice way. This is question 8, bacteria in the dish. Now, the dish contains 5,000 bacteria. I don't know how they know exactly. Anyway, the number of bacteria increases by 18% per hour. It's rapid growth. How many bacteria will there be in the dish after 6 hours? Now, please, let's not work out 18% of 5,000. Add it on, get an answer. One cycle, and then we work out 18% of this bigger amount. Work it out, add it on, get an answer. Then work out 18% of this even bigger amount, get an answer, add it on. Don't want that. Let's just do it the smart way. I've got 5,000 bacteria. Here's part A, by the way. And I'm going to multiply by 118%. That's 1.18. And I'm going to multiply by 118% again, and again, and again, and again, 6 times. Remember, this percentage increases per hour. I'm going to go for 6 hours. So just put it to the power of 6 and do it the clever way. So here's my machine trying to handle this. So 5,000 times 1.18, that's my 118%, raised to the power of 6 on my calculator. Right, how many bacteria will there be in the dish after 6 hours? Well, here we go. 13,497.7. Well, I don't want 0.7 bacterium, so I'm going to round it off to that, which is approximately 13,500 bacteria. Okay, it's more sensible to round it off like that. The original question is to one significant figure, so I'm happy to go 13,500 bacteria. Happy day? Happy? Okay, that's it. So let me just move on a little bit to the next question, and part B then. Here we go. Show that it will take 13 hours for the number of bacteria to exceed 50,000. Now, okay, show that it's going to take 13 hours. I'm not going to do 13 calculations in the same way I didn't do 6 separate calculations here, one for each hour. So I'm going to take my 5,000 original bacteria. I'm going to assume it's going to increase at the same rate. We don't know that for sure. In fact, biologically speaking, if they start getting overcrowded, then they start using nutritional resources, they start using up oxygen, and then they start sitting in their own waste, so to speak, in their own excreted compounds, and then they start killing each other off because for that reason. So it won't keep rising at a constant fixed rate anyway, and so that's just biology for you. Anyway, so 5,000 times 1.18 to the power of 13. So let's see what we get there first of all. Show that it takes over 13 hours to exceed 50,000. Well, let's start with 13 hours first of all. So 5,000 times 1.18 raised to the power of 13. That's in my calculator. I have got 42,997 bacteria, okay? After 13 hours, rounding off to the nearest whole bacterium. So let's just go over 13 hours, in other words 14 hours. Let's just try 14 hours. So here we go. So again, 5,000 times 1.18 powered up to 14. I've got it, here it is. 50,736 bacteria. Is that alright? So it will take over 13 hours, but 13 hours is too low and 14 hours is too high. So let's just try and give a conclusion now. Right, it will take over 13 hours, but less than 14 hours for the number of bacteria to exceed 50,000. Is that right? So I need to do a bit of trial and improvement. 13 hours, not quite enough. 14 hours, I've got 700 bacteria too many, never mind about that. But you can't say it will take 14 hours. No, after 14 hours we've gone above 50,000. So it will definitely take over 13 hours. I've proved it, but it will take less than 14 hours to just exceed 50,000 by, say, a couple of bacteria. And that's it. I'm going to stop there, and then I'll do a couple of questions in a second vid, and then we'll move on. Okay? Catch you later.